activated. At this point of time in the mission, the launch vehicle would have acquired 2.1 kilometers per second relative velocity. For the present mission, the burn time for GS2 is 140 seconds. It is separated 4 minutes 53 seconds into the flight. The third stage is the cryogenic upper stage, which plays a significant role in the mission. Its high specific impulse, together with a long burn time of more than 13 minutes, it adds tremendous relative velocity to the operation adds 376.55 kilometers
stand
in
by
altitude
for the time mark.
and increases relative velocity from 3.5 kilometers per second to 7.5 kilometers per second. An operational philosophy unique to the GSLV-F16 NISAR mission is that CUS stage is operated by 11% for the duration of 405 seconds. About 11 minutes into flight, the cryogenic upper stage shuts down. The satellite NISAR is separated to be injected into an altitude of 745.5 kilometers with a relative velocity of 7.57 kilometers per second.
Minus 25 seconds.
We are mere 25 seconds from the launch.
Minus 20 seconds.
सभी दर्शक हमारे साथ बने रहिए.
Minus 15 seconds.
So please stay tuned with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S139 motor ignited.
That's a magnificent of the GSLV-F16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों
You see L40
सफल प्रज्वलन और GSLV
successful launching.
की ओर बढ़ता हुआ.
This is going to the destination.
हम यहाँ कंपन महसूस कर पा रहे हैं.
We are experiencing the vibration here in this mission station.
S139 solid core motor and 4 L40 liquid strap-ons thrusting together. 7,800 kilonewton cumulative thrust.
First stage performance normal.
Sharon is in Menato.
The day of launch wind biasing program that is fed into the onboard computers helped the rocket to veer through the atmosphere with minimal aerodynamic loads.
प्रथम चरण का कोर बूस्टर लगभग
The first stage core booster will be ignited.
L40 चरण
L40 stage 150 seconds it will be calm. So after that it will be separated from the craft.
अपने अपेक्षित पथ का अनुकरण करता हुआ
First stage performance normal.
Currently the rocket is in open loop guidance. Shar ground station is tracking.
S139 burnout.
कोर बूस्टर का प्रज्वलन समाप्त हो चुका है.
So it has been completed. The
director that the
ignition of core booster
has stopped its operation. The 4 L40s are thrusting still.
First stage performance normal.
प्रथम चरण का कार्य निष्पादन पूरी तरह सामान्य.
The first stage is normal. This is going to its launched direction. L40 is ignited. So it will be 50 seconds duration.
GS2 ignited. GS1 separated. 1S. IS 1/2 main separated.
जी हाँ, अभी आपने सुना रेंज ऑपरेशन.
Yes, you saw.
पुष्टि की है.
Range operation director has
किया जा चुका है.
Payload fairing.
confirmed.
का प्रज्वलन शुरू हो चुका है.
The second stage ignition has been started.
The flight, the GS1 has undergone a hot separation and GS2 commenced its operation and thrusting nominally. The payload fairing has also been separated and closed loop guidance has been initiated.
जी हाँ, इस दौरान
Second
Yes,
stage
in this
performance
हमें
normal.
वातावरण से बाहर, इसलिए पेलोड फेयरिंग या ऊष्मा कवच की आवश्यकता
payload fairing.
थी, इसलिए इसे यान से पृथक कर दिया जाता है।
So this has been separated
और अब
from
यान
the
गाइडेंस के अंतर्गत है और स्वतः ही अपना दिशा
spacecraft,
निर्धारण कर रहा है।
and then this is going to its
Powered by
own
the Vikas
direction.
engine that uses the Earth storable propellant combination of UH-25 and N2O4. The second stage of GSLV develops 846 kilonewton thrust in vacuum. Burn time for this mission of GS2 is 140 seconds.
Plus 4 minutes.
दर्शकों का उत्साह देखते ही बनता है यहाँ पर।
So we are seeing the encouraging viewers here.
द्वितीय चरण सामान्य निष्पादन करता हुआ अग्रसर
So
है।
second stage is in its normal ignition.
इसमें इस चरण में US-25
In
तथा
this
N2O4 ईंधन का प्रयोग किया जाता है।
in this stage, US-24 and N2 is used.
लगभग 150 सेकंड का होगा।
So around 150 seconds time
जैसा कि
for
हमने
this
पहले
ignition,
बताया था,
like we previously mentioned, second stage.
द्वितीय चरण को अनुमोदित कर दिया जाएगा।
So after finishing the second stage, the third stage would be
Third stage or the
started.
GS2 thrust cutoff.
operation. The second
GS2
stage has completed
Custard
its
ignition
operation and
commanded.
has been jettisoned from the ongoing vehicle.
द्वितीय चरण के सफलतापूर्वक प्रदर्शन के पश्चात
Second stage completion, successful completion has been achieved. This is the third stage, the last stage has been, this is the complex stage. So we can see the viewers
The cryogenic
encouraging
upper stage has
viewers.
commenced its operation.
Cryo stage operating at uprated level.
The Cus stage with CE 7.5 engine with liquid hydrogen as fuel and liquid oxygen as oxidizer with a nominal thrust of 73.55 kilonewton. In this mission, there will be a thrust upratement of 11%, that is
Cryo stage performance normal.
4 kilonewtons for about 405 seconds.
Plus 6 minutes.
वर्तमान में तृतीय चरण क्रायो अपर स्टेज
This is the third stage,
75 किलोन्यूटन का प्रणोद उत्पन्न कर रहा है।
75 kilonewton
लगभग
ignition.
850 मिनट सेकंड्स तक जारी रहेगा।
So this will be continued for 850 seconds.
वर्तमान में सापेक्ष गति 3.49 किलोमीटर प्रति सेकंड तथा
So
ऊंचाई
currently the relative velocity is 3.49 kilometer per second.
Cryo stage performance
An
normal.
altitude of 528 kilometers. Char and Trivandrum stations continue to extend tracking and telemetry support. When the cryo stage had commenced action, the instantaneous relative velocity was 3.5 kilometers per second. By the end of thrust upratement, it becomes 4.5 kilometers per second. For the next 400 seconds that follow, there is a significant addition in the relative velocity of up to 7.5 kilometers per second.
Cryo stage performance normal.
सभी विशिष्ट वैज्ञानिक यहाँ उपस्थित
So specific scientists are present here to witness this great event. So the third stage is completely normal.
इसे भली भांति ट्रैक कर रहे हैं।
So they are tracking.
The altitude gained during thrust upratement is about 400 kilometers in cryostage operational range. When the thrust upratement ends, there is a considerable increase in relative velocity at a marginal loss of altitude.
Plus 8 minutes.
तृतीय चरण की यात्रा लगभग 850 सेकंड तक जारी रहेगी।
So the third stage would be continued up until 850 seconds.
synthetic
Cryo
aperture
stage
radar,
performance normal.
जिसे संक्षिप्त में नाइसार कहते हैं, वैज्ञानिकों को
So
प्राकृतिक खतरों
this is
और
called NISAR.
घटनाओं जैसे भूकंप, ज्वालामुखी
So
विस्फोट और भूस्खलन जैसी प्राकृतिक घटनाओं को बेहतर ढंग से समझने के लिए
the natural disasters like landslide,
को भेदने की क्षमता के कारण यह तूफान और बाढ़ जैसी मौसमी
this
आपदाओं
penetrates the clouds,
व सटीक जानकारी उपलब्ध कराने में
and
सक्षम
this
होगा।
will provide the
इससे तत्काल
real-time information
घटनाओं को
about
मदद मिलेगी। यह बर्फ की चादर, ग्लेशियर और समुद्री बर्फ में परिवर्तन
9
जैसे
the changes in the glaciers,
प्रदान करेगा।
the thickness of ice,
साथ ही वनों की कटाई, वनाग्नि तथा
so the
बर्फ से ढकी हुई जमीनों का
deforestation,
सक्षम होगा।
uh,
यह एक
the
अग्रणी
problems of deforestation can also be mitigated.
बारे में वैज्ञानिक जानकारी का खजाना प्रदान करेगा।
So this will provide the scientific information.
वैज्ञानिक आपस में जुड़ चुके हैं तथा आपसी
The scientists are combined together. So this is a very ambitious mission.
NISAR, or the NASA-ISRO Synthetic Aperture Radar, is a remarkable milestone in the Indo-US space ties. Designed on the I-3K mainframe bus, NISAR will render services for the next 5 years according to free and open data policy. NISAR provides
10
a means of disentangling and clarifying spatially and temporally complex phenomena ranging from ecosystem disturbances to ice sheet collapse and natural hazards including earthquakes, tsunamis, volcanoes, and landslides. ISRO has identified a range of applications of particular relevance to India that the mission
Cryo
will
stage
address,
performance normal.
including monitoring agricultural biomass over India, monitoring and assessing disasters to which India responds, studying snow and glaciers in the Himalayas, and studying Indian coastal and nearshore oceans by monitoring annual changes in bathymetry along the deltaic regions, shoreline, and accretion. The changes that Earth is undergoing in its ecosystem, deformation, and cryospheric sciences emphasizes the urgent and constant need to observe Earth from the vantage of space in order to thrive on our changing planets in decades to come. NISAR offers centimeter-level precision capable of detecting subtle ground shifts and environmental changes. Data from NISAR will provide critical insights to help India and US plan for natural
Cryo
and
stage performance
human-caused
normal.
hazards. Today, when the GSLV-F16 rocket of ISRO places NISAR in its intended orbit, a critical deployment event antenna. That checking out the engineering systems, testing the radars independently and jointly. This phase will last for 90 days after the launch. Extensive calibration and validation activities will take place
Cryo stage
throughout
operating
the
at
first 5
nominal
months.
level.
The schedule of science observations alone will be driven by a variety of inputs, including L and S band target maps, radar mode tables, and spacecraft and ground station constraints and capabilities.
तृतीय चरण क्रायो अपर स्टेज
Third stage,
कार्य निष्पादन पूरी तरह
cryo
सामान्य
stage, ignition is completely normal.
4.9
The relative velocity
प्रति सेकंड तथा
4.9
787 किलोमीटर
kilometer per second, and altitude is 788 kilometer.
पृथ्वी की भूमि तथा बर्फ का अध्ययन करने के लिए सिंथेटिक अपर्चर रडार
to
क्षमताओं का उपयोग करते हुए
synthetic aperture radar capacity is used.
और फिर
So
सतह
this
के
will
पृष्ठ से
give the data.
परिवर्तित संकेतों को प्राप्त कर 3D चित्र
The changed signals will be sent.
12 मीटर व्यास वाले अनपरलेबल
So there is a 12-meter wide reflector antenna is attached
में 2 बार एक ही जगह से निकल सकता
2
है
times
और इस समयों में
so
चित्र में बदलाव से पृथ्वी में की सतह पर आए बदलावों
in
को
Earth
कर सकते हैं
we
नासा
can study.
नासा और इसरो द्वारा तैयार
NISAR,
सबसे उन्नत रडार प्रणाली वाला उपग्रह है
this is
सिंथेटिक अपर्चर रडार की तुलना में अत्यधिक शक्तिशाली है
a very powerful synthetic radars available here. This is the
L band
25 centimeter wavelength L-band radar system used by NASA.
S band radar system
So the
हर एक प्रणाली
other one is the NISAR.
Stage performance
जैसे कि
normal.
मिट्टी में नमी सतह का खुरदरापन और गति निसार
So
सूर्य तुल्यकालिक कक्षा में काम करने जा रहा है इसके एंटीना एक खास विन्यास में
its antenna is
अभूतपूर्व अवलोकन
Antarctica.
यह अंटार्कटिका
We can observe the Antarctica as well.
सटीक अध्ययन के लिए बहुत महत्वपूर्ण माना जा रहा है
This is very important to study the
दैनिक आधार पर सबसे
melting of ice in Antarctica as well.
साल के मुख्य मिशन के दौरान 100
So 3 years main mission, the data would be provided.
डेटा के बराबर है इतने
So
बड़े
this
डेटाबेस
is
के
the
कारण
80
इसे
terabyte
के माध्यम
data.
से संसाधित संग्रहित और वितरित किया जाएगा
This will be distributed.
सभी एस बैंड और एल बैंड डेटा
All the S-band and L-band data will be
भारत सरकार
national remote sensing, and so government of India will be used.
सिंथेटिक अपर्चर
It
रडार
will be provided to other countries as well.
Normal.
नासा ने 1900
NASA has 1978. They have started
ने विमान व अंतरिक्ष से विज्ञान क्षेत्रों के अध्ययन के लिए अग्रणी रहे हैं
for the study of space.
में विस्तृत श्रृंखला 2012 में रडार
2012
और 2022
asset 1 in 2022
नाइसार व्यापक के साथ उच्च रिजोल्यूशन के डेटा निरंतर
so high resolution data would be available.
We are 16 minutes, 15 seconds past the launch. Now the cryogenic upper stage is currently thrusting. The vehicle trajectory correctly follows the prediction.
Cryo stage performance normal.
तृतीय व अंतिम चरण GSLV Mark II का क्रायो अपर स्टेज के नाम से जाना जाता है
Cryo upper stage
वर्तमान में पूरी तरह
currently completely normal performance. All the
सामान्य निष्पादन करते हुए
system,
यान को उद्दिष्ट कक्षा की ओर
so the vehicle is targeted to the
क्षणों में
designated orbit.
कक्षा की स्थितियां प्राप्त करते ही क्रायोजेनिक इंजन को बंद कर दिया जाएगा
Cryogenic engine would be closed.
The launch vehicle is at an altitude of 748 kilometers.
कक्षा की स्थितियां प्राप्त होते ही
As soon as the situation in the orbit,
Awaiting the satellite separation event.
Cryo stage performance normal.
Plus 18 minutes.
वर्तमान में सापेक्ष गति 7.35 किलोमीटर प्रति सेकंड तथा ऊंचाई 745 किलोमीटर होती है
Stage performance normal.
so currently 7.35 kilometer per second is the relative velocity, and
Performing nominally.
Stage thrust cutoff.
The thrust has
Standard
been cut off
injection
of the
condition
cryo stage, and next event is the NISAR separation, which is perhaps very close.
जी हाँ, जैसा अपेक्षित था।
Yes, as expected.
GSLV-F16 NISR mission accomplished successfully.
जी हाँ, इसकी पुष्टि हो चुकी है।
This has been confirmed.
प्राप्त की जा चुकी है।
The NISAR has been separated.
The NISR satellites into its designated injection orbit. The GSLV-F16 NISR mission is successfully accomplished.
History has been written today as NISAR has been placed in the orbit successfully. Many hearty congratulations to ISRO, NASA, and the users worldwide who will derive benefits of the Earth observation with this state-of-the-art NASA-ISRO synthetic aperture radar satellite. Do stay tuned. Tune in for the address by Secretary DOS and Chairman ISRO and mission executives. We take leave from you. Namaskar.
इस प्रक्षेपण के साथ नाइसार का प्रमोशन
With this launching, the
आप सभी
launch mission has been successful.
हार्दिक शुभकामनाएं।
So congratulations to all the viewers and the scientists. So we will be taking you to the address of the scientists.
Either none. CS announced. Project director also, project director, satellite project. Please, on. Very good evening to all of you. I am extremely happy to announce that GSLV-F16 vehicle has successfully and precisely injected the NASA-ISRO synthetic aperture radar satellite, NISAR satellite, weighing 2,300 kg into its intended orbit. Let me congratulate all the teams from ISRO and NASA JPL on this outstanding success. This is our 102nd launch from Sriharikota and the 18th mission of GSLV. As all of you may recall, we had the previous GSLV F15 mission on 29th January 2025, which was the 100th successful mission launched from Sriharikota, and also the first launch after the new management, including me, took over as the chairman of ISRO. This is the first GSLV mission to the Sun synchronous polar orbit. Till date, all the GSLV missions have been to GTO. Being the first SSPO mission, several analyses and studies were carried out to make this mission a grand successful mission, including the cryogenic upper stage corrections. A host of mission simulations were carried out very systematically and meticulously, and today's successful mission is accomplished. All the vehicle system performance were quite normal, as expected and as predicted. And today, we achieved the intended orbit. Actually, we have got the orbit position of less than 3 kilometers against the permissible level of 20 kilometers. Perigee, the specification is 742 kilometers. We have got 740 kilometers. Apogee, 745 kilometers is the specification. We have got 747 kilometers. And all the parameters are as expected and in the right line. And this accomplishment is a teamwork, culmination of the teamwork of both ISRO and JPL NASA. The NISAR satellite is a significant milestone for both Department of Space and NASA JPL, being the first joint development project undertaken by the two major spacefaring nations. NISAR is an all-weather, day-night imaging satellite that will scan the entire Earth at 12-day interval. The satellite integrates ISRO's S-band synthetic aperture radar payload with NASA's L-band SAR payload and 12-meter unfurlable reflected antenna to become the first of its kind, a dual-frequency SAR satellite. NISAR will enable the scientific community to detect the surface variations, sea ice detection, invest natural hazards, monitor soil moisture, and many other applications. The potential applications from the satellite are huge, and the global scientific community is eagerly awaiting the satellite data for their respective research and usage. The implementation arrangement between ISRO and NASA for a joint Earth observation satellite mission was signed on 30th September 2014. Between then, it was signed by the then Chairman ISRO, Secretary Department of Space, Dr. K. Radhakrishnan, who is sitting in front of us, and with the NASA Administrator, Mr. Charles Bolden. In fact, we were so happy to participate in that function, which happened in Toronto. Since then, the realization of satellite in ISRO progressed steadily under the outstanding leadership of subsequent Chairman, Sri Kiran Kumar Sir, who is also present in the audience, Dr. K. Sivan, Dr. Somnath, and also under different project directors. On this occasion, let me congratulate all of them. Also salute each and every one of the team members who have contributed for this significant achievement. Let me also congratulate all the technical teams, administrative teams both in NASA, JPL, and ISRO, who worked shoulder to shoulder to build the satellite at UR Rao Satellite Center over the past so many years. Our mission has brought the two space agencies much closer than ever before, and the continuous interactions at various levels during the course of project execution has enriched both sides. On behalf of Department of Space and ISRO, let me thank the NASA JPL team and all other stakeholders in the project for their excellent contribution to the joint mission. Also congratulate them on the successful launch. We wish the scientific community from both sides the exciting days ahead. Let me also congratulate the ISRO teams from SAC, URSC, VSSC, IASU, IPRC, LPSC, ISTRAC, and all the teams involved in the payload development, satellite integration, realization of solid, liquid, and cryogenic stages, inertial systems, and the launch vehicle itself. Let me take the opportunity to congratulate the Chairman Launch Authorization Board, all the center directors who are with me. It's a teamwork done by ISRO along with the NASA. I express my heartfelt gratitude to the Honorable Prime Minister, Sri Narendra Modi ji, who as the Minister of Space has provided outstanding, encouraging support for the entire project for its successful execution today. Also, let me thank Honorable Minister of State, Dr. Jitendra Singh ji, and officials, PMO officials who are working hand in hand with the Department of Space, and all our family members, entire team members of ISRO, and the academia and industrial participants who have contributed for this. I think at this point of time, this success is demonstrating a teamwork, an international teamwork between two spacefaring nations, and surely this data is going to be highly useful for the scientific community of the globe. And when every 12 days when the data is going to come, it is not going to be used by one or two countries. The entire globe is going to benefit out of this great accomplishment. And at this point, once again, let me congratulate all the team members, our family members, industrial partners, academia team, and the NASA team for the outstanding work. At this point, before I hand over to my team, let me invite Cassie Swiles, Deputy Assistant Administrator at NASA, for expressing her thoughts on the journey so far in this joint outstanding mission. Madam, please, floor is yours. Yeah, please.
Well, I first have to start with go ISRO, go NASA, go NISAR. So I am honored to be here today in the ISRO Mission Control Center. It's just truly been an incredible visit so far. And I have to tell you, I had an opportunity. I'm sitting next to our charge. It's just an honor to have you here. So thank you, sir, for being here. The former ISRO chairman, I looked at him right after the launch and I said, so how does it feel to not be on console? He said, well, it's a different seat. So it's good to not be in the hot seat. So I'm glad you got to watch the launch and enjoy it. But on behalf of NASA, I want to congratulate all of the teams. It has been just an incredible decade culminating in this moment, from the technical collaborations, the cultural understandings, getting to know each other, building that team across continents, across time zones, missing nights, missing weekends with families, holidays. It is truly something that every single person in this room should be proud of. I am so proud. I was so proud to be out there watching this launch, dragonflies flying above, just picture perfect. And I could not be more proud of these teams. You know, and this mission, it's truly a pathfinder, not just in regards to our technical, because those are truly incredible. This Earth science mission is one of a kind and really shows the world what our two nations can do. But more so than that, it really is a pathfinder for the relationship building that we see across our two nations, across India, the United States, building upon decades of collaborations that already existed. And I cannot be more proud to be here representing the U.S. and really representing the teams that have been working so closely behind the scenes to make this happen. I also want to thank, I saw, several family members, both, last night on the U.S. side, I saw several family members here. So I want to thank the families. It's no small sacrifice seeing your loved ones work day in and day out on a mission that takes over a decade to build. So thank you for your support of the incredible, technical, talented people in this room. And I really, really cannot wait for continued partnerships as we go forward, building on Chandrayaan, Axiom 4, and now NISAR. So thank you. Congratulations. Go NISAR. Go India. Go the United States.
So congratulations once again. Now,
if you're just joining us, I'm Raquel Villanueva with Dr. Sue Owen, live from NASA's Jet Propulsion Laboratory in Southern California. We were just watching celebratory speeches from India after our colleagues at the Indian Space Research Organization launched NISAR about 30 minutes ago. NISAR is a joint mission between NASA and ISRO. It's a powerful Earth-observing satellite built to track changes on our planet. And launch was a spectacular sight. Right, Sue?
It was really amazing. And, we were here at the Mission Control Center here watching the launch, and it was just so exciting. We had our lucky peanuts. It's a special NASA tradition to have peanuts for launch. And so, it was really moving to see NISAR finally making its way into space.
It was great to see you get emotional watching it too, eating your lucky peanuts. And we weren't the only ones celebrating here at JPL. Here's a look at our mission control and friends and family inside Von Karman Auditorium reacting to launch.
Yeah, everybody was just so excited. You can see people clapping and cheering. It was a great event.
I know, we're right next door to the mission control, so we could really hear them cheering at each milestone. Now, our home planet is constantly changing in a variety of ways, some subtle, others dramatic. NISAR will enable us to comprehensively monitor Earth's land and ice surfaces, building a detailed record of large and small changes over time.
With NISAR, we're tracking the changes of the solid Earth and how it's moving, ecosystems, ice cover, and any other thing that's changing at the scale of a centimeter on the Earth in a way that we've never been able to see before. Because of these very subtle motions we can measure, we're able to understand what's happening below the surface of the Earth at great precision. We can see subsidence, and that allows us then to manage resources of what's happening below the Earth.
Scientists want to study the movements of the Earth's surface to understand the processes that could trigger earthquakes, volcanoes, and landslides.
And that allows us then to understand risks associated with natural hazards,
which in turn can help in mitigation measures and early response. Other changes over the Earth's surface include melting of glaciers and ice sheets, changes in forest biomass, soil moisture, and shoreline changes.
It's based on radar. So it has two different frequency radars, and it basically looks through clouds and sees the surface of the Earth. What you're seeing is an animation of how the radar collects data, and you can see these beams coming down from the antenna and coming back, and on the ground you can see the swath, and that's where it collects the data, and when it combines them all together you get what we need for the science.
We can see day and night through clouds, and we're covering all of the land and all of the ice-covered surfaces of Earth every week. NISAR is quite unique in that it has two radars, one provided by NASA, one provided by ISRO, the Indian Space Research Organization.
NASA and ISRO have collaborated in this mission. Till last year, we were there at JPL, NASA, where the radars got integrated and tested and were shipped back to India. And now the spacecraft is getting integrated with the instruments and they are being tested together. NISAR is going to be launched from Sriharikota, which is a ISRO launch pad, and it is going to be launched by GSLV Mark II. So we are just looking forward for the launch of NISAR in the forthcoming year.
NISAR is measuring the changes on the Earth's surface, which are either factors or indicators of climate change. The society will also immensely benefit due to its contribution towards disaster management and providing food and water security.
These things are global problems that the global community needs to come together to resolve.
Now it looks like we are no more belonging to two different worlds, and we all belong to the space community. That's it.
There's the excitement about what we are going to learn that we didn't even anticipate we were going to learn.
This mission has been years in the making, and one of the people who helped bring it to life is with us right now. Charles Alachi is the former director of JPL, a member of the NISAR science team, and we are sitting in a room named after him. Charles, it is great to have you with us.
Well, thank you. Thank you.
How are you feeling after witnessing launch?
Well, to say ecstatic is an understatement. This is a great day. I want to start by thanking our colleagues in ISRO and India for the perfect launch. We have been working together on this for almost 15 years. And I was delighted to see many of the faces that we worked with, at the Indian Control Center. And many of the people here at JPL who have spent, more than a decade, including the team members sitting here, spent more than a decade to make this happen. This is a great day.
Fantastic.
So, Dr. Alachi, you actually pioneered the evolution of radar technology here at JPL. How does NISAR embody that tradition of innovation?
Well, it's really in the spirit of their Mighty Six, which is the spirit, of JPL. I remember when I first came here, all the radar team used to sit in one room. We were like 7, 8 people. And now you look at it, how much advances were made. NASA and JPL really were the foundational start of spaceborne synthetic aperture radar, starting with CSAT and a series of shuttle imaging radar mission. We developed and demonstrated multispectral, meaning colored radar. We developed the interferometric techniques that are being used now. And now using SAR for Earth observation is being used by industry, many nations who are participating in this endeavor. But NISAR is going to do the next quantum jump. We are going to be able to actually map the planet every week down to changes in the centimeters. That's fraction of an inch. So we are going to be watching our planet actually breathing, as a result of natural changes or human-driven changes, floods, pumping water. So it's really going to open a whole new domain that is going to really impact in a major way how do we observe our planet.
Thank you. That's great.
Absolutely. And, you were mentioning those small changes. So NISAR will detect changes on the Earth's surface with remarkable precision. So how will NISAR's data benefit society for years to come in the near future and for the future generations?
Well, let's take one example, the floods which happened recently in Texas. NISAR will be able to actually monitor the changes of the area which are being flooded, even under vegetation. And then when earthquakes happen, we would be able to monitor the surface motion which results from earthquake, so we can send the information, to the rescuers, so they know where are, the major damage which have happened. Let's take example where people are pumping water, farmers are pumping water. We'll be able to monitor how much the water table is being depleted and how much is being refilled, during the winter when there are rain, both here and in India and worldwide. So I think it's going to impact us in a significant way, in a positive way, in helping us, better manage our resources, prevent, or not necessarily prevent, but actually how do we manage natural disaster? I mean, recently there was a big earthquake in Japan, in Russia. So there is possibility of tides and flooding around coastal region. So a satellite like NISAR will be able to monitor that on a regular basis. So it's really going to impact not only our scientific understanding, but our day-to-day life. So I would envision that people would be getting on their iPhone, map of the region or on a global basis to see what are the changes and how do we mitigate disasters which are happening.
So many communities will benefit from NISAR's data.
Absolutely, worldwide.
Well, thank you so much for sharing your insights with us today, Charles.
Well, thank you very much, and go NISAR.
Go NISAR. Thank you. So, Sue, we are waiting for our ISRO colleagues to confirm acquisition of signal, but looking ahead, what comes next for NISAR?
So over the next 10 days, the satellite will be, they'll be checking out the satellite, and then in about 10 days, they will start deploying the antenna reflector. So the boom will, you can see here on the video here, the boom will be, the hinges will be fired so that the boom will get into place. And then once that is into place, you'll see the reflector itself start to bloom, and that will take place over days. They want to do this slowly and carefully to make sure that everything is working well. And then after that, they'll be turning on the radar instruments separately and together, making sure all of the radar technology is working well. And then after 90 days, we will start collecting science observations.
So there's a lot to look forward to.
Yes, there is.
Well, that wraps up our coverage for today. Thank you for joining me on the desk today, Sue.
Thank you, Raquel. It's been really great having you here as a launch buddy.
Yes, witnessing the launch together is fantastic. So this marks the beginning of a mission that will help us better understand our dynamic and changing planet. To hear the latest updates on NISAR, visit go.nasa.gov/NISAR blog. You might hear cheering in the background, perhaps a new milestone. We'll leave you alone with a replay of launch. Have a great day.
8 seconds पर L40s का प्रज्वलन हम देखेंगे.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S139 motor ignited.
5 seconds.
That's a magnificent
Tracking.
of the GSLV-F16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों L40 और S139 का सफल प्रज्वलन और GSLV F16 का उत्थापन द्वितीय प्रमोचन मंच से, और ये अपने गंतव्य की ओर बढ़ता हुआ. हम यहाँ कंपन महसूस कर पा रहे हैं मिशन नियंत्रण केंद्र पर.
The first stage of GSLV with S139 solid core motor and 4 L40 liquid strap-ons thrusting together. 7,800 kilonewton cumulative thrust. NISAR will render services for the next
prepared and it has been assured.
सभी स्वास्थ्य जांच पूरी की जा चुकी है. एयर ट्रैफिक कंट्रोलर तथा जल
ट्रैफिक कंट्रोलर्स
अनुमति प्राप्त की जा चुकी है. हमारे मौसम विभाग से भी पूर्व सूचना प्राप्त की गई है और इस दौरान मौसम पूरी तरह
weather is
अनुकूल बताया गया है.
Ideal for the launch.
Automatic launch sequence जारी है.
Automatic launch sequence is continuous.
-16 minutes.
Automatic launch sequence.
Authorization.
Computer
Authorizes
जांच पूरी
to
की जाएंगी.
initiate automatic launch sequence for the launch of GSLV F16 NISAR mission.
SDA servers activated. MC confirms data from SHAR-1 and SHAR-2.
GSLV F16 mission at the second launch pad. It's getting ready for its first ever mission to sun-synchronous polar orbit.
Automatic launch sequence initiated for GSLV F16 and NISAR mission.
ALS in auto mode.
Tank PLO operations commenced.
NISAR उपग्रह L और S बैंड
NISAR satellite
अपर्चर रडार वाला उपग्रह है जो उच्च विभेदन के साथ बड़े ब्रह्मांड को प्राप्त करने के लिए CSAR तकनीक से संचालित होगा। नासा के जेट प्रणोदन प्रयोगशाला जेट प्रोपल्शन
NASA's Jet Propulsion Laboratory
सहयोग से तैयार
with ISRO. This has been prepared.
राष्ट्रीय जरूरतों को पूरा करेगा।
This not only addresses the national necessity, this will be providing the data to the whole world.
संस्कृतियों का सही सम्मिश्रण और वैज्ञानिक
It's a combination of two cultures and then the best creation.
.7-meter tall GSLV is a 3-stage launch vehicle of 420.5 tons lift-off mass. The first stage, GS1, comprises of S-139 solid booster and 4 strap-ons of liquid L-40. The second stage, GS2, is Earth storable liquid stage of GL-40 HT.
L-40 EGC actuation in
The
progress.
third stage, GS3, otherwise called CUS-15, and is powered by cryogenic propellant combination of LOX and liquid hydrogen. The payload fairing is of ogive shape with 4-meter diameter.
यह रचना आपके सामने प्रस्तुत है GSLV F16 प्रमोचक्यान की
GSLV-F16
7 मीटर। इसका कुल उत्थापन भार
51.7 meter the height, so its mass is 420.5 tons.
स्ट्रैप-ऑन्स लगे हुए हैं। द्वितीय चरण में L-40
the second stage
ऊपर स्टेज
L-40 and then
वाला चरण है
so this is the
और ऊपर
cryo engine stage, third stage.
पूरी तरह सुरक्षित है।
So our NISAR is fully protected.
Payload pairing 4 मीटर
Payload pairing
वाली ओजो payload pairing
4 meter.
किया जा रहा है।
L-40 EGC actuation completed.
सभी गणमान्य व्यक्ति यहाँ उपस्थित लॉन्च का अनुभव लेने यहाँ
everybody are attending, the distinguished guests.
GSLV F16 की उड़ान दक्षिणी
GSLV F16 flight would be from the south direction to keep it in the tracking range. Radar tracking station
मॉरिशस और अंटार्कटिका में स्थित हैं।
Antarctica,
निगरानी रखेंगे
Mauritius.
और हम तक सभी आंकड़े वास्तविक समय पर उपलब्ध
So we will be getting all the data on the real time.
We are 11 minutes 45 seconds from the launch. In the preceding several months, both ISRO and NASA have disseminated information and data characteristics to enable prospective users to take full advantage of the data gathered by NISAR when it becomes available.
सभी वैज्ञानिक अपने कंसोल पर
all the scientists are studying their data.
अभी तक
all the technologies are working fine.
लॉन्च व्यू गैलरी का दृश्य
You're seeing the gallery of the launch, the encouragement, all the students here, big numbers they've been presented here, they're gathered here
अनुभव लेने के लिए
to experience the launch of this satellite.
स्वानुभव लेने वाला यह पल
exuberant spirits of the students here at the launch view gallery at Sriharikota.
उत्साह देखते ही बनता है छात्रों का।
So the inspired students encouraged here.
पल मिला है जब
this is the moment they've been getting.
यह प्रमोशन देख सकते हैं।
You can see this launch.
T minus 10 minutes.
GS2 radar engine actuation in progress.
ISRO is bringing to you a curtain raiser for the mission NISAR for your better understanding about the mission.
In an era where climate change dominates global discourse, humanity faces an increasing vulnerability to natural disasters. To address these mounting challenges, NASA and ISRO have joined forces in an extraordinary collaboration to launch the NASA-ISRO Synthetic Aperture Radar Satellite, NISAR. This groundbreaking low Earth orbit LEO observatory promises to revolutionize the way we understand our dynamic planet. Equipped with state-of-the-art LNS-band synthetic aperture radar, SAR systems, NISAR will use the sweep SAR technique to deliver high-resolution images across vast swaths of the Earth's surface. Incredibly, it will map the entire globe every 12 days, offering unprecedented consistency in spatial and temporal data. NISAR's mission is nothing short of transformative. From tracking glacial melt and monitoring agricultural landscapes to analyzing seismic shifts and managing disaster response, it will empower scientists, researchers, and policymakers with vital insights. By precisely measuring minuscule movements and colossal environmental events alike, NISAR will help us decode Earth's complex ecosystems and natural hazards. The flagship mission sees NASA contributing the L-band SAR, engineering payloads, critical systems like GPS receivers, and the solid-state recorder. ISRO is supplying the S-band SAR, spacecraft bus, and will launch the satellite aboard through its vehicle GSLV-F16 from Sriharikota. A majestic 12-meter unfurlable reflector antenna will unite the dual-band systems, enabling powerful Earth observations from orbit. The geosynchronous satellite launch vehicle, GSLV-F16, features a three-stage configuration. Its first stage comprises a solid rocket motor at the core, support 4 liquid strap-on boosters. The second stage operates on liquid propellant, while the third and final stage is powered by an indigenously developed cryogenic upper stage. The payload fairing for the GSLV-F16 NISAR mission features a 4-meter diameter OGIV configuration. The launch will take place from the second launch pad at India's spaceport, SDSC Shar at Sriharikota. It is the first GSLV mission to be launched into a sun-synchronous polar orbit. NISAR is not just a satellite. It's a symbol of global unity, scientific excellence, and hope. It promises to safeguard our future by helping humanity live more wisely with nature.